Good evening, everyone. Welcome to the Carolina Weather Group. This is the Wednesday, March the 8th edition, second week of the National Weather Podcast Month. We're happy to have you on tonight. A great show lined up. We have Ryan Hickman on from Allison House. He's going to be kind of telling us the ins and the outs and maybe some of the new products they are developing. So we're happy to have Ryan with us tonight. This is a live broadcast, so if you are watching live tonight, you have any questions, please feel free to send them our way. You can send them via our Twitter account at Carolina WX Group, or send them to us on Facebook. We'll make sure to get those and monitor those throughout the show. And if you're listening on the rebroadcast or the podcast, you can submit those to Ryan. Ryan himself will let him kind of share his social media stuff towards the end of the show. So happy to have Ryan with us. I know a big talk, maybe we can talk about it before the show's over, of maybe winter's last gasp here in the Southeast, as we may see a little bit of snow before winter wraps up. So that's been a hot topic, but we'll kind of put that off to the side and maybe briefly cover that towards the end of the show. So I do want to open it up to our panelists, let them kind of talk about what's been going on in the past week. We do have a familiar face back. He's on spring break, so I'm going to toss it first to Kit. Kit, welcome back, and how's spring break treating you?
Thank you, Scotty. Spring break's treating me all right. I'm getting some much-needed sleep and doing some much-needed cleaning in my room. Other than that, I don't really have any plans, but to just stick it out at the apartment. I'm going to go talk to my mom's class on Friday morning just about weather. They're learning weather this week, so a bunch of first graders I'm going to try and explain QG theory to.
You should probably just go with cloudy with a chance of meatballs.
There you go.
Yeah, I'm probably going to give something about that. I might try and find a lightning picture or two to put up on the TV screen. But other than that, schedule's clearing up, so I'll probably be back for at least the rest of March.
Well, we're happy to have you back, Kid. Thanks for coming on. Let's toss it up to our good buddy Peter, who's up in the Northeast. Peter, not only are you bracing for one round of wintry weather this weekend, but you guys may get something towards the end of the week as well.
Yeah, we've been hearing about a lot of stuff coming up next week or so, but it's been so nice around here. The trees are blooming. There's buds on the trees and everything. It's been so nice. And now we have to hear about this stuff coming up. But that's typical New Jersey and whatever. So we have to deal with that first. But let me share the screen here and show you that we got this little pesky system coming up for Friday that could start as rain and then change over to snow. Nothing big deal. But then Scotty was saying we got that storm to the south that was supposed to be a major storm for New Jersey.
Look over North Carolina. That's snow. We don't want that.
There you go. All snow there. So that was way up into like New York.
Of course we want that. We definitely want that.
It's not like it's March or anything. And then I have to go on a little rant here for a second. There's already people talking about this storm for Tuesday. I mean, seriously, Tuesday, and we're already talking about it like it's a big deal. I can't. So, yeah, that's somewhere down the line, but we're not going to worry about that yet. So we got a lot of stuff coming up. But I said the last time I was on here, we're probably not going to get any more snow the rest of the winter, but I jinxed it. So sorry, everybody.
How's that turned out for you?
That's okay.
Yeah, not good. So sorry.
Scotty, I want to play devil's advocate here for a second, because this is a problem in my mind. You know, if it was rain coming next Tuesday, we'd be perfectly fine showing you what the models show and everything shows and putting in our 7-day forecast and all that. But the problem is, and I understand the forecasting troubles that go along with it, but the fact that it's snow causes us all to try and hide the forecast from people, it seems like, until we're a few days out. And I have a big problem with that. I don't know the solution to that yet, but as someone who tries to communicate things, I have an issue with that. So that's my rant for the night.
I totally get it. Yeah. But you know, as well as we do in the Northeast, it may be a little bit different than down here in the Southeast, where we don't get snow all the time. So everybody just freaks out, you know, and then, you know, it's just, I don't know. But
there's people putting detailed forecasts out right now for next week.
I totally agree with Ricky, though. I mean, you shouldn't hide it. But then again, you know, we know how the Southeast reacts when
it is different for sure based off, location. But I hope that in the next 5 years, we as a weather enterprise or forecaster or whoever can just come up with a solution to try and do some of this long range forecasting, because I fear that we are going to put so much emphasis on the short range forecasting in these next 2 to 3 days that our long term forecasting is going to suffer, to where our pattern identification and our 4 to 7 day time frame is just going to become a thing that the apps are doing and not so much us.
I agree. That sounds like a good topic for a show. We'll have to
There you go.
All right, before I get to Ricky, because I'll let Ricky introduce our guest, I'm going to go down to the warm, sunny coastline of Charleston, South Carolina. We're all jealous because that's where we all wish we could be right now. Shay Gibson, how are you doing?
I'm doing good, Scotty. Yeah, it's been pretty mild here, pretty warm. We had a little cool down over the weekend. Cold front came today. Of course, every cold front that's been coming into the southeast the last week or so has just been dying out. So it fizzled out to nothing today. I think there was a brief shower in the early morning hours. We got up to 77 degrees today. I know you're jealous, but I will share screen. Just like Peter, I have something I wanted to share as well. Let me know when you can see it.
Yep, you're good.
And this is our GFS 2-meter temperature guidance for the next 10 days. Now, you get about 3-4 days out, things start to become a little bit erroneous. This was showing low 50s earlier across from Tuesday and Wednesday of next week, but you can see the downward trend this weekend as a cool air mass moves down from the north down to the southeast. Of course, North Carolina is under sort of a gun for a wintry weather event. And I mean, the ground is so warm. Everything is so warm right now. I mean, we've started spring here. We've got pollen build up everywhere. We've got flowers blooming, azaleas, you name it. It's spring. A lot of people started planting. I think they planted too early because you see these temperatures dropping down near freezing. And earlier we showed temperatures down to the upper 20s and low 30s. And so this could fluctuate. This time of the year, these temperatures tend to go up. So we may be spared another freeze. But it always goes to show that you can never trust March fully. We've actually had a snowstorm in 1993. It was more of a windstorm with snow mixed in. But, the weather's so volatile in the springtime until you get to, about beginning to middle of April. And then things start to really warm up from there. But you can kind of get an idea of looking at this chart that we still cannot trust it until winter is definitely over. So spring solstice, is March 20th. And we are still in winter, but meteorological spring.
Spring equinox.
Spring equinox, I'm sorry.
That's there you go.
Well, thank you, Shay. Yeah, jealous of the 77. It was 70 degrees here today in Western North Carolina, but it was a little bit breezy, so it felt a little bit cooler than that. But I definitely agree. This is a interesting setup, and I'll bring Ricky into it because Ricky's kind of in my same area. We're kind of looking at the same type of issues. A couple of days ago, well, actually Saturday, I was doing some work with Tim Buckley at WFMY, and we were watching it, and we had to forecast a sunny and 72 for Saturday. 5 days later, now we're talking about the potential of snow. So it has been a very fluid situation. It does look like the models are continuing to trend south, and who knows, March has been crazy, and this winter overall has been really crazy. So nothing definitely would surprise me here. I don't think we'll see a big snow, and I think I don't see what we've seen in January. But if all the conditions come together, you can see a light coating, maybe a couple inches or something like that, in some areas in the Carolinas, and definitely up where Ricky's at there in Eastern Tennessee. So Ricky, I'll toss it to you, and then I'll let you go ahead and go with Ryan, and we'll start the show.
All right. Yeah, it's interesting, Scotty. I mean, we could have snow if the right setup occurs and the right cold air moves in all the way down to like Knoxville and further south, which is almost unheard of in the month of March. So it's a tricky little forecast that's taking shape. But we'll see. My gut feeling tells me that we're going to have some snow across Southwest Virginia for sure. I feel like we're going to have some P-type issues for parts of Northeast Tennessee, including the Knoxville and Tri-Cities markets as we start off the event. But I feel like it's probably going to change over to snow as we go on. And Sunday morning's going to be a little messy, and I'll probably be into work earlier than I typically am on a Sunday. So fun times are ahead, even as we go into the second week of March almost. Well, second week of March. So, all right, enough about snow. Let's bring in someone who knows a little bit about snow based off of where they live and further out towards the west. Ryan Hickman joins us from Allison House tonight. Talk a little bit about what Allison House is. I've worked with them and have been a subscriber on and off for the past couple of years, and always loved all the data they provided. So we're happy to have Ryan and you on tonight to talk a little bit about what you guys do.
Yeah, good to be on. Thanks.
So first off, for people who haven't heard of Allison House, tell us a little bit about what goes on with Allison House, where the company came from, and what you guys have done now with your company.
Well, the company started about 10 years ago. Tyler Allison started mostly from the fact that the NWS public servers weren't great at providing data reliably during severe weather events. So it was born out of the need for more reliable data than the public servers can handle, mostly because we get a huge demand on our public infrastructure during these events. Companies use them just like Allison House. The Weather Channel, everyone. We all pay taxes for this data, so that need just grew and grew to the point that the National Weather Service couldn't handle it. They didn't quite expect it. So we started pulling in the data from our satellite dish, NOAA port dish, and we're able to keep up with the demand. Basically, we know how many customers we have, so we can provide the data reliably, and we scale to that need. Just by pulling that data in over the satellite. So it's a more reliable form of communication when their internet infrastructure goes down. We still get the data over the satellite, and we're able to pass that on to our customers.
And there have been several instances where that's happened in the past couple of years, especially during some larger tornado outbreaks where some of the public feeds, Iowa State, the level 2 servers have gone down. Talk a little bit about how you guys keep everything going, how the redundancy comes into play, and then how the data just keep flowing even with some of the public servers being down.
Well, I'd say we run at probably a 2N infrastructure, and basically that just means we run at twice the capacity that we're expected to handle. That's mostly just because we want to achieve this mark that is reliable enough for storm chasers that are out in the field, meteorologists that are on there, EMs that are making big decisions based on the data that they're receiving. They just can't have a big delay or any outages. So really just kind of scaling to that capacity. We use cloud infrastructure. We are auto scaling. So essentially that just means that once that demand starts coming in, our infrastructure automatically grows to achieve that 2N, that twice the capacity that we actually need, so that we can serve every request, whether it's for severe thunderstorm or tornado warnings, or radar data, level 2, level 3 radar data. So it's just a matter of making sure that there's always a server there to handle the request. And I think we've done a pretty good job of it over the last 10 years.
How many requests do you guys get on a busy severe weather day? How many hits are there from your feeds? Is it something that can be tracked?
Yeah. So we monitor that pretty well, just so that we're able to handle that. And so to that end, we get about 200,000 requests a second. Obviously, we handle radar scopes warnings. So whether or not you're a subscriber of ours, radar scope uses our Allison House warnings, just because we've been a reliable source for that over the years. And if you are a subscriber of ours, you use our radar data, so you know how reliable it is. And there's 10 other applications that use us. So Gibson Ridge, obviously, a big user of ours. If you've heard of us through Gibson Ridge, you know that we provide very reliable level 2 and level 3 radar feed that maybe sometimes Iowa State isn't able to handle the level 2 requests, and that's because they're free and they're an educational network. So it like I said, just being able to handle twice the capacity is very important.
So talk a little bit about the integration between some of these partners. You guys have teamed up with GR, you've teamed up with Radar Scope, a few other weather softwares that are out there. How does that collaboration come into play? Do the subscriber or does the, I guess, product creator just approach you guys, be like, hey, I want to integrate some of your data or have the ability to?
Yeah, absolutely. That's generally where the relationship starts. We like I said, we've been in business for 10 years, so we've been known as a reliable form of communication of radar data. And for that reason, we've had various application developers approach us. Mike Gibson of Gibson Ridge was one of the first that we started providing data to. Like I said, our warning server is among the best. And we've really just grown that relationship by offering this data to anyone who wanted to integrate us. And you do have to be a customer of ours, but in general, the fact that it integrates with multiple applications, that your subscription gets you access to reliable radar scope warnings and radar data and SPC outlooks and what have you, and then you can turn around and go to your computer and use Gibson Ridge software with that same subscription. It's very versatile, and for that reason, I think we've grown that relationship because the application developers understand the need to provide that reliable radar data to their customers, especially storm chasers.
And that's one of the things that is great about the products is they are cross-platform. Between Radar Scope and GR, you can use the same type of account, and it's all under one account. Talk a little bit though about how many different types of data you guys pull in from that NOAA port server. What types of data are you processing on a daily basis, and then what some of the processing that goes with that involves?
Well, we use our own satellite dish. We actually have 2 satellite dishes where we pull in this data over the NOAA port network, and getting that data in and to a server is the first step in the puzzle of actually re-providing this data to the customers. We pull in level 2 and level 3 radar. That level 2 unfortunately doesn't come over NOAA port, so it doesn't come over a satellite dish. It's only available on fiber infrastructure that National Weather Service provides. But we're able to pull level 3 radar, which is compressed level 2 essentially, and warnings, all of the models basically, GFS, NAM, and RAP and HER. And we're also able to even pull over the MRMS data, which is just a derived, it's multi-radar, multi-sensor. It's a derived level 2 product, basically a mosaic of the country's level 2 radar infrastructure. And it even spans into Canada, so that's incredibly beneficial data when it comes to actually, demonstrating to people what is going on around the country, spanning the entire infrastructure of the National Weather Service plus even Canada. So what involves actually decoding that data is just years of experience and seeing what that data actually looks like and dealing with the different data formats that come across. Level 2 and level 3 radar, we don't actually decode, we just pass it straight on to radar programs. But when it comes to model data and warnings and things like that, we've learned, some tricks over the years that gives us the benefit of actually providing it more reliably.
You mentioned data from Canada. Does that come in a different format? Is that different than United States National Weather Service data?
So Canada doesn't run WSR 88Ds, although they did just approve upgrades to the radar infrastructure within the last month, I believe. That data actually comes in as the MRMS mosaic. So it comes merged with our level 2 radar products, basically reflectivity products for the most part. So just so that the MRMS product spans into Canada, so you can see things coming across the border or anything like that.
Okay. Kit, did you, or sorry, not Kit. Shay, did you have something you wanted to talk about?
Yeah, I mean, I just wanted to ask what's your relationship with Gibson Ridge, and how do you get that data? Are you just get the data and then pass it on to Gibson Ridge in radar scope, or how does all of this integration of data work?
So we've always brought in the data, and our initial relationship was with Gibson Ridge, and that was mostly just because that was the only program around at the time. Mike Gibson was one of the first to develop a radar application that was actually usable for everyone who was using it at the time, which were generally more experienced people, using even in the field. But our relationship with RadarScope developed out of just RadarScope wasn't always owned by WDT, so in the beginning they were base velocity, and that they were a small radar team. They knew how to decode the data, but they needed a reliable method of getting the data to them. And like I said before, the National Weather Service infrastructure wasn't great at handling that before. But so our initial relationship with Gibson Ridge mostly just was born from the fact that we had the level 2 radar data, and most other people didn't, because it comes over fiber, and National Weather Service doesn't distribute it directly themselves. There's no National Weather Service server for level 2 radar data, which is, that's just the way things are right now. But we were able to get our hands on the data, and we wanted to provide that to the customer. So you combine that with our Lightning data, which we've offered from the very beginning. Our Lightning data is a summarized Lightning product that makes it cheaper. So we show strikes every 2.2 miles instead of actually showing every individual strike. That Lightning data that includes every single strike is very valuable to the Lightning data providers who actually triangulate that data, mostly just because there's insurance reasons behind that. You get a lightning strike on a house, the insurance company is going to want to know, if that lightning strike actually occurred. So we were able to provide that data for a lot cheaper before anyone else. We pioneered the cheap lightning data, and you combine that with the level 2 radar data, the highest resolution that we can possibly get our hands on, and we knew that we needed to get this to the community. We've always been a huge community advocate, and that's why we've always opened up everything to the application developers to actually develop their software and then include us if they want to include us.
That reminds me of our latest geostationary satellite, the GO-16, that has a geostationary lightning mapper that's going to be coming into play here. Is that something you're going to be looking forward to as well, to integrate into your products?
Yeah, absolutely. So I've spent probably the last 5 days, restless nights, decoding the GOES 16 data, and I'm pretty proud of what we've accomplished. I'm hopeful for the lightning mapper hitting the satellite, the NOAA port satellite, so that we can actually get our hands on that data. Lately, we've only had the base imager. So, there's, I believe, 16 bands there for us to play with for now. But yeah, we're definitely looking forward to playing with the lightning data once it comes across.
16 bands, not enough. Need more data.
Yeah, exactly, right?
Kid had a question you want to bring in.
Yeah, so like you're talking with the GOES 16, they have the lightning mapper. A friend of mine has a little thing he got on Amazon for like $40. That's a lightning detector. On what level of technology is the network of Allison House of the lightning detectors on that scale? Like, is it something that's you just place here and there, or is it like how is the network of lightning detectors organized?
So Allison House actually uses a professional lightning network. We use the Earth Network's Total Lightning Network, which spans the entire globe. In fact, they have enough detectors out that the data is triangulated, so it's within, I believe, a 10-meter error, margin of error as far as the location of the strike. You combine that with the fact that it can detect the difference between cloud-to-ground strikes and intra-cloud or cloud-to-cloud strikes. These are all important factors in determining what a storm is doing, the damage that might be occurring, and the difference between this professional network and those detectors that you can buy at home is, first off, the professional network is triangulating that data. It's much more precise. The home box kit that you're getting is somewhat prone to interference from other electronic devices in the area, power lines most notably. So filtering out that noise is kind of important, because you're detecting the difference between the cloud-to-ground strike and intra-cloud strike. And having those power lines adjacent to you and interfering with that detection just completely throws everything off. So while home box kits for actually detecting lightning are great, and they're evolving and they're getting better, they're not on the scale of a global lightning network, which uses very efficient detection algorithms and hardware to actually detect those strikes. It's just incomparable.
Ryan, we've had the opportunity at Charlotte Motor Speedway to use some of your high-resolution lightning data. Talk a little bit how that varies from the more, I guess, the lower level data that's provided that most people use.
So Allison House subscriptions, it's $12 a month. It gets you the 2.2 mile summary. So you'll see an icon for lightning, for a single icon for lightning within a 2.2 mile radius around that location, that actual icon. The difference between that summarization and the precision, the high resolution network that you're using, is that we're not summarizing any of that data. You are seeing exactly where the lightning strike occurred. You're seeing when it happened. And then in addition to that, you're seeing the polarity, whether it's positive or negative, and the amperage. And those are significant factors in determining storm strength as well. But it's also significant in protecting life and property. When you're dealing with protecting your guests, you want nothing less than the highest resolution, because you want to know when that first strike hits in your radius that you're provided, and you want to guarantee the safety of those guests and get them to a safe location. That 2.2 mile summarization is the difference between 0 and 2 miles. So that buys you time, and that's important.
Yeah, time is very valuable when you're trying to evacuate a grandstand or clear people out from a field or something like that. So it certainly can come in handy. All right, let's segue just a little bit to some of the data from the past to some of the data of the future. As you mentioned, and we've been chatting a little bit on Facebook about, you've been dabbling into GO16 data for a couple of days now, trying to decode some of it. Talk a little bit about how that process has been. Any surprising quirks of the GO16 data that have come up?
So traditionally, we've received the GOES data over our satellite dish, just like we do the GO16 data. However, the GOES data comes in a single file. That's mostly just because of the resolution. Our current satellites that we have up there aren't as awesome as this GO16 GOES-R satellite. So when the GOES-16 satellite data started coming over NOAAPort, the first thing that we had to learn was that it came in tiles. So it came in segments that we needed to merge together to build the full image. And that's just because of how strong this satellite actually is. It's very precise. It's got a great resolution. It's a 0.5 kilometer visible versus 1 kilometer visible. So it's twice the resolution on the visible satellite. And then you add to that the fact that the satellite actually comes in twice as fast, actually 3 times as fast. Traditionally, we've had images coming in every 15 minutes. And with GO16, we have images coming in every 5 minutes. That's obviously very fast and at a very high resolution. So we're getting a considerable amount of data over a satellite dish that traditionally hasn't serviced this much data. So actually decoding that data has been a new challenge just because of the tiles and that difference, and the fact that it's coming in so quick.
You had an image that you shared a couple days ago. I don't know if you can share your screen as well on here, and maybe we can pull it up. If not, if we can't get it, but I'd like to show kind of how that data, when it hit your servers, made it be a lot more, I guess, used is a word for something. It really hit the servers, and you could see when that GO16 data hit the servers because of the massive amounts of data that were coming in, right?
Yeah. So here, let's see if I can pull this up here. Sorry.
Left-hand side is a little green button that says screen share. You click on that.
Yeah. Does that work?
Yep, we got you. Think so.
See the graph?
Yeah, Twitter is what we're looking at. We don't see the graph.
Okay.
I see it's not popping up in the.
Okay.
You may have to do like an entire window and then share it that way. Sometimes it doesn't like to do the applications that try to open up something inside of them.
All right, I'll do that. Well, yeah, the amount of data was considerably higher just because, like I said, the quality of the data, it's both increasing to 3 times the frequency, but also, all right, entire screen yet? No.
I think Peter's got it. Peter, go through a couple more images. We're looking for the ones. Go down a little bit more. Keep going.
I'm used to the inception when I start screen sharing. A little further.
A little bit more.
Lots of Ghost 16 data I've been sharing lately. You can imagine why. There it is, right there.
Compared to what you were getting before, how much of a significant jump is that? It almost looks like double, right?
It is about double, yeah.
That's remarkable in just the resolution. Why was it? Any idea why it was so much more the initial phase there? Was it just all the raw data initially coming in?
It's a combination of the fact that, like I said, they haven't shared this amount of data over the dish before, so they were probably toying with what they could actually put through, and that combined with the fact that they also weren't planning on sharing all of the mesoscale sectors, which they're actually doing smaller sectors that come in every minute, which are more, focused in on areas. It's for, fire, weather, and things like that.
Sorry, go ahead.
No, you go ahead.
So we see the data now, and it's double what it was before. When we get geostationary lightning mapper data and those mesoscale bands, how much more is this incoming data going to increase?
I don't see it increasing a whole lot more. I think that the images you've seen with the geostationary lightning mapper may have been combined with other bands, but I'm not entirely sure. It's hard to know for sure. We haven't actually had this data, like I said, sent like that before. So, honestly, your guess is as good as mine. But when the data does come over, we'll definitely be right on the tail, trying to make sure that we get it decoded and so that everyone can see it, because this is totally new for our lifetime, obviously, and I just think that this data is, just shows what the United States can do as far as weather data goes, and I sure hope that the tax issues and what have you get figured out, because this data needs to continue to be flowing to the people who need to use it.
Sure.
And Ryan, what sort of solutions do you have for this storage of this data? I know that you guys provide up to 2 weeks of level 2 and level 3 radar imaging for folks that want to, subscribers that want to get that information. But now this is entering into a whole new arena. Are you going into supercomputing, or are you clouding, or how do you store that much information?
So about a year ago, actually, nearly exactly a year ago, we switched to cloud computing. Traditionally, we had used what's called bare metal, basically just servers that were built on a rack that we knew were reliable. They could handle all of the storage of that data, and they could handle the throughput and everything to actually get the data to the consumer the fastest in the market. Because, like I said, time is everything.
Now,
as far as this year goes, we switched to cloud computing. The reason we switched to cloud is because we can get solid state drives cheaper to actually store this data and even get it to you faster. You combine that with the fact that our infrastructure automatically scales to our demand with cloud computing. We've increased our uptime by 0.2%, and that's significant when it comes to actually providing the state of the consumer and getting it to you reliably, whether it's lightning data, radar data, warnings, whatever.
Go ahead, Kit.
One question I had was when we had that graph from your Twitter earlier, it showed that spike from, you said it was the Ghost 16 coming on.
Yeah, that was, I believe it was around 19Z, 18Z.
Okay.
They just turned it on, yeah.
Well, I know that Ghost is still getting some tweaks worked out. do we know if that's an actual data that there was just more lightning being detected, or is it just the whatever lightning detector on goes? Is it just having some tweaks that needs worked out?
So the graph that was shown actually doesn't include any of the lightning data. That's because they have not provided that data over the satellite dish at all yet. So that was the 16 bands that included just the imager that were infrared, water vapor, visible. There's ozone, various other bands that were provided, but the GLM band, as they call it, to detect the lightning, that hasn't been provided yet, and it's more of an algorithm kind of thing.
Okay, gotcha.
Vicky, do you have any?
I did. I was trying to bring up something, and I was trying to click around and bring it back up. I couldn't get to
Saw
my
you muted.
Yep. All right. So, Ryan, let's talk a little bit about the future of weather data. Obviously, we're going to have more and more and more data and larger files coming in the future. Where do you, as a data programmer and someone who has to sort through the data, see us going? Or more importantly, where should we go in the world of computing weather data?
Well, there is a lot of value in our numerical models and how they are actually done. As you see with the European, the ECMWF, they've got a great infrastructure behind them, which allows them to perform more precise calculations at a quicker speed than the United States is unfortunately able to do at this time. And while we improve the quality of the GFS and the NAM here and there, the European is a global model down to the same kilometer scale, basically, as our high resolution rapid refresh. So I see our data growing as far as requiring supercomputing, but that supercomputing also being graphics processor driven. Most of the modeling done in the United States is done through a CPU, which isn't as good as the GPU, or the graphics processor, at handling these numerical calculations and figuring things out on a higher resolution or a finer scale, and further out even. So I see that GPU processing of our numerical models being the next frontier of actually improving the United States weather data and weather prediction. And I know we'll get there. We have great minds behind this. Unidata is invaluable when it comes to contributions to this community. So I know that we will get there. It's just a matter of the programmers realizing that CPU computing is just not going to bring us to the level that we need to be at when compared to this conglomerate, or this, the European model for that, the whole globe, being at the scale that our high resolution rapid refresh model is. And satellite data is going to be a big contributor to that too. Those models require satellite data.
For someone like you who then has to get that data and process it, how much more of a workload and a data load will advances put on you guys?
We're always ready to grow as far as computing goes. Cloud computing has offered great advances in the field of commercial weather data, and that's just because it's cheaper to buy a computer or a processor or disk for a shorter period of time, and then not pay for it when you're not using it. So when you have high resolution rapid refresh model coming in every hour, of course you're going to have to be waiting for that every hour. But when you have the NAM and the GFS and everything else coming in every 6 hours, you really only need the compute resources for a short period of time while you process that. So, like I said, cloud computing it's easy to grow our infrastructure to support the demand that we need to support, and we're always ready to do that because we have the benefit of actually having the satellite dish, 2 satellite dishes, to provide this data to the weather community, and we're merely just trying to get that data out so that someone can do something with it because it's important.
Okay. Let me share my screen real quick, and we're gonna show Allison House maps and let you talk a little bit about how this idea came up and some of the data that's provided on Allison House maps.
So Allison House maps covers both model data and some real-time data. And as you're seeing here, this is the GO16 long-wave infrared data. Takes a little bit longer to load. It's a lot of data. You're seeing it in the tile form that I was describing earlier, that those tiles come in over our dish. Like I said, it's important because each frame is 5 minutes of data, and our current geostationary satellite only handles 15 minutes of data. So it's important that we get this finer scale and actually see these differences in between frame to frame so that we can make better decisions.
From a programming standpoint, how did you come up with the idea for maps? I mean, it seems like a kind of everything into one place kind of idea.
Yeah. So GR Earth is a Windows program, and there's quite a big Mac market now. And personally, as a Mac user, booting up a Windows virtual machine just to run GR Earth or whatever other program was just seemed unnecessary, and it was bogging down my computer. So actually putting this in a web browser means that you can run it on your phone too. And that's significant because it just obviously having the same interface between your computer and your phone is you don't have to learn anything new. I feel like everyone before had to actually have different applications for the different different things they wanted to view. I want to view satellite data. I want to view MRMS data. I want to view current observations, model data. I don't want to have to learn a new interface to do all those things. And being able to do it between your desktop computer and your phone was really the big selling point for me to actually build this.
And not just phones, but I mean tablets now. Tablets are becoming such a large part of everyday life, iPads and Android tablets. I assume this works on those too, right?
Yeah, it does. So we built this for iOS and Android and Mac and PC. I mean, it's cross-platform. Mostly just, like I said, because we didn't want to learn a new interface between the two. So you'll have to go back a day on the Modus imagery just because it's going to be loading.
There we go. Wow.
Yeah. So combining all the satellite data and everything, I just haven't seen anything out there. And there were some early model websites that actually decoded the models and put them up, but the quality didn't increase at all when you zoomed in. And I knew it could be done. there's other websites out there like Tropical Tidbits and what have you, that Weather Bell, all the others, they have this data, but it's regionally sectored and it's single images. I don't know. I'm maybe a little different. I like to play with the data a little more, so I like to be able to overlay the layers that I want to overlay and combine data to the point where I see what I want to see.
And one of the nice things about this too, how I feel, is that it allows you to. I was going somewhere with this point, and then I totally forgot it. Boy,
Ricky, just for our viewers, Ricky, what exactly is this product that you're using right here that they'll know which product to use?
Well, what I was looking at a moment ago, what you're seeing on the images, and because, like Ryan said, they're large data files, it takes a moment to load. This was the full disk image from Go 16, but this is one of Allison House products that they supply now. Instead of, it used to be, and Ryan, you can go more into this, it used to be bundled with one of your Storm Chaser subscription or Storm Hunter subscription into GR Earth. Now you guys are offering Allison House maps instead, correct?
Yeah. So traditionally we've offered a Storm Hunter subscription included GR Earth or Allison House maps. You got to choose, and our radar data as well as our place files for use in Gibson Ridge, or if you want to use our data in Radarscope, or there's Pickle on Android, there's Weatherwall on iOS. There's just so many applications that integrate with Allison House data. But we offer GR Earth with Storm Hunter, and over the past couple of years I've been developing this, and we decided that this was probably good enough that we could start offering this with GR Earth instead. I mean, with Storm Hunter instead. So this is Allison House Maps. It's browser based. Like I said, it works on multiple platforms, and really the key was just being able to use the data universally. Out in the field, I'm a storm chaser. I like to be able to see some model data, the current observations, or whatever while you're out in the field, and that's always proved really valuable. So I wanted to combine that data without having to have multiple applications.
So now I remember my point I was going to make. Because it's a web-based software and not a like a install software, how easy is it to add a new product versus a regular software?
Well, Go 16, when I did it, was available the night that it came out. So I would say incredibly easy. It's very easy to add a product without having Apple having to go through the Apple approval process or the Google approval process, and just get the data to you so that you can actually get your hands on it right away. Because, like I said, we've got the satellite dish. We just want you to be able to use the data. It's really a matter of just getting it decoded and usable into an application, and we're breaking that barrier.
It all depends on how much sleep you need to get on a daily basis, right? That's the key.
I mean, I don't need a lot, so.
When the dog's still pacing around at 2 in the morning, you're like, okay, he's still awake. So, well, he was awake. Now he is. All right. Well, we are coming up on 9 o'clock. So, last question from me: any cool new things coming from Allison House in the future?
I mean, we're always working on things. Unfortunately, we work in the winter so that we don't interfere with the severe weather season. We've made a lot of strides in the last 6 months as far as making our lightning data more precise by, instead of the 2.2 mile summary, while we still do that, we show the lightning icon at the most recent location, so it doesn't have this gridded look. And Go 16 maps the global maps that you were just showing. That's 2 weeks old, maybe. So we've we work hard in the winter, but as far as weather data goes, it kind of stalls out during the severe weather season, just so that everything is reliable and gets to you on time.
If it's not broken, don't fix it.
Exactly.
All right. Any other questions from the rest of our panel here? Otherwise, I'll toss it to Scotty.
That's been a cool insight to Allison House. I've seen it on Radar Scope, just looking in the menu. I've never really known what it was. So thank you for coming on.
Thank you.
I really like how Radar Scope, even Radar Scope Pro, how that application works. But your data coming into that's invaluable. I mean, we see it time and time again on the coastline where lightning strikes along the beach and coast. You get these bolts out of the blue. I mean, 20, 30, 40 miles out in distance. And it's great because we can capture that and say, here's the time that it happened and relay that to the public. Then don't be fooled if the storm is well inland. Now we have the proof behind it. So we appreciate everything that you guys do and keep it going. You guys are doing great.
Thanks.
Yeah, just to echo what Ricky said, we really use your stuff out at the Speedway, especially during the race week. So we appreciate that and all of the products you guys do. I did have one question, not pertaining to Allison House or anything. You said you was a storm chaser.
Mm-hmm.
So as we end the show, give us a storm chasing story. Something maybe sticks out or maybe one of your most memorable chases.
Well, the El Reno tornado. Unfortunately, the El Reno tornado was most memorable. I was born and raised in Oklahoma. I moved to Colorado about 5 years ago. My stepbrother lived in Oklahoma. I came down around my birthday to chase every year, the last 5 years. So we got out just east of El Reno real early that day. Obviously, we could, the feeling, just the humidity and everything. It's living in Oklahoma that long, when it's a stormy day, when it's going to be tornadic. We got out just west of El Reno, right as the tornadic storm approached, right by the airport, just southwest of the airport, and seeing that thing with multiple tornadoes, satellite tornadoes on the ground around it was very humbling. We knew immediately, just leave, just get out. It wasn't worth it, and unfortunately, that proved to be one of the more unpredictable tornadoes, and we wish things could have been different, but that will always stick out in my mind. The El Reno tornado, May 31st, 2013.
Wow. Yeah. Myself and Joey Mosseller, he panelist from time to time, we were able to go out to the memorial that they had built there a couple of years ago and get to see that. And, just to hear stories from people who experienced that, it was, definitely once in a lifetime. So thanks for sharing that. It's always interesting to hear different chasers' point of view and stuff. So we appreciate having you on tonight, Ryan, and hopefully maybe this time next year we can have you back on and talk about some cool new things with Allison House.
That'd be great.
I would like before the show's over, maybe for those who are watching, if they want to get in touch with you guys, what's the best ways to get in touch with Allison House, and then maybe you, if you want to share any social media or anything like that.
All right. Well, on Twitter, we're just at Allison House. And I'm at Ryan Hickman, Hickman. And we have Facebook as well. You can always email us, and AllisonHouse.com. We're always willing to take criticism and get do what we can to get this data to you faster.
Sorry about that. Didn't mean to cough. Well, we appreciate it, Ryan. Thank you for coming on. We've enjoyed it tonight, and and learned a lot. These allergies are killing me here in North Carolina. So
that's the weird thing, Scotty. We're talking about snow, and allergies in place. Like the pollen is snowing out from the sky anyway.
My car looks horrible right now. It's all yellow. It's crazy, but Ryan, we do appreciate it. Thanks so much for coming on. I do want to do a quick mention. National Weather Podcast Month has really taken off. I think Shay has got the article the Weather Geeks over, I guess, the past day or so, promoted the National Weather Podcast Month and really got a lot of hits. We want to thank Weather Hype for creating this really cool site and kind of talking about each podcast and the schedule of this this upcoming month. So those who are watching tonight who has never seen the Carolina Weather Group, we welcome you and we hope that you come back and watch us. We're on every Wednesday night, well, almost every Wednesday night at 8 p.m. Eastern time. There's sometimes we go on special nights, and I'm sorry, and my cough drops are wearing off. But yeah,
Scotty was sitting here saying he's like, I hope I can make it through the entire show without coughing.
I know, almost. So, but yeah, thanks for those guys for making this, and really enjoyed being a part of this group, and hope to see it continue throughout the years. So, congratulations to everyone who has had a successful show already, and look forward to continuing it throughout the rest of the month. So, Shay, I'm going to let you take the next two topics for our upcoming shows, since you've been actively pursuing our guests and talking with them. So I'll let you take it, and then we'll wrap it up from there.
Yeah, March 15th, next Wednesday, we have John Jensenius. He is NOAA's lightning expert, and we've been on his wait list for about 8.5 months now. So we're really looking forward to it. I got a confirmation from him just recently that he'll be on next week. He is the man when it comes to lightning and getting the information out about anything having to do with it. The lightning strikes, deaths. He's the foremost sort of the steward of lightning information. So he'll be joining us next week. Really good guest. The week after that, we start talking about sea level rise with NOAA's Doug Marcy of Coastal Management Services here in Charleston, South Carolina, actually. And he's going to discuss flood and inundation products and anything having to do with coastal resiliency. He's an expert at this, and so we're going to find out a lot more about what's going on there. I think that there's a growing concern every year with coastal flooding, as we are seeing sea levels rise. So it'll be really nice to hear what he has to say about that, to sort of verify things that we are already researching.
Yeah, thank you for that, Shay. We're looking forward to those great guests. I mean, those are two top-notch guests. So I'm very happy to have Doug and John joining us over the next few weeks. And as we wrap up the National Podcast Weather Month, we are going to be having the Stormfront Freaks, a fellow podcast. I'm going to be joining us and talking about them. I think, Shay, you and I are doing Weather Junkies next Thursday, I believe.
Let's see here. We've got Carolina Weather Group on the 22nd. No, that's ours.
Yeah.
I'm trying to keep up with it myself. We got a whole schedule here.
I think we're doing next Thursday, I believe, is what I have scheduled. And then Ricky, you are doing Weather Brains as well. I'm not sure of the date of that. Do you know?
Next on the 20th, I'm joining Weather Brains with Chuck Doswell. So that should always be an interesting show. So
that will be a good show. You'll have to recruit Chuck onto our show after.
Okay.
All right. So, and we'll continue this throughout the month. Who knows? We may have a few more podcasts jump on, or we may jump on a few other podcasts. So, very cool to do this. Hopefully, this will continue to grow throughout the coming years. Then, as we look into April, we're going to start talking about Weather Awareness Month. It's got some great guests coming up. Chris White, veteran storm chaser in the state of Virginia, will be joining us. Trish Palmer from the National Weather Service in Greenville-Spartanburg will be joining us. And then we're working on, we always try to do one of the severe weather outbreaks. We're working on the April 7th, 2006 breakout. First affected places like Nashville, and then moved into Georgia and South Carolina, even in Charleston. So, so we're looking forward to doing that as well, trying to confirm our guests for that. So a lot of stuff coming up here on the Carolina Weather Group, so we hope that you'll continue watching us. So for everyone here, enjoy the snow if you get any. Last winter's hoorah. So everyone have a great week, and tweet us. Hey, tweet us some pictures or Facebook us some pictures if you get snow this weekend. I know Ricky would appreciate it because he's going to be on TV this weekend. So send us some photos. Let us know what it's doing in your area. So for everyone here at the Carolina Weather Group, the guys are making fun of me here in the side chat. I'm reading it as I talk to you guys. So for everyone here on the Carolina Weather Group, thanks so much for joining us, and we'll see you next week.